Okay, this is part 2 of the video of effects on area as a result of dimensional change. I'm going to go back to example 3 because I don't think we finished it. A rectangle has a width of 4 feet. So here's my rectangle. It has a width of 4 feet and a perimeter of 24. So if these are both 4, so 8 plus 2x is equal to 24. So if we subtract 8, we get 16. So x is 8. So here is my original rectangle that has dimensions of 8, 8, 4, and 4. Okay. So here we go. And okay, what is the perimeter of a similar rectangle with a length of 12 feet? So here's my new one. And this rectangle, it's not supposed to be a rectangle, has a length of 12 feet. So the 12 and the 8 are the corresponding sides. So that means that my scale factor is either 8 over 12 or 12 over 8. Let's go ahead and simplify those to, they're divisible by 4. So 2/3 or 3/2. And it just depends on, do we want to get bigger or smaller? And so what we need is, we have this width is 4, and so we want it to get bigger. So we're going to multiply 4 times 3/2 because that's going to give us a bigger number. And we're going to get 12 over 2, which is 6. And so that means that these are the 12, sorry. I can't think. This is 12 and this is 6. These are the dimensions of my new rectangle. So what is the perimeter of a similar rectangle? 12 plus 12 is 24, 30, 36. So the perimeter, using new color, of this is 36. And the perimeter of this one was 16, 17, 24. So we could do it this way by actually drawing the picture, or we can use the rule, which says if we take our original perimeter, which was 24, and we multiply it by the scale factor, we wanted it to get bigger, and so the scale factor would be 3 over 2, and this actually said perimeter, and I am working area. So let's just do it both ways. So I'm looking at the area would be 3, well, okay, we can just do perimeter. It would be 24 times 3/2 because we're not squaring anything. So let's just look at that. I don't know what I was thinking. So 24 times 3/2. I'm sorry, it's late. Is 36, exactly like we said. Now, if we were looking at area, we would have squared it. Okay, let's look at the next quick check. All right. A rectangle has a length of 4 feet. So let me draw that one here. So I'm doing the quick check, but I'm drawing it here. Has a length of 4 feet and a perimeter of 14. So that's 4 and that's 4. So 8 plus 2x equals 14 is going to be 2x is equal to 6. And so x is equal to 3. So that means this. So we can go ahead and see that the perimeter on this would be 8, 9, 10, 14. So again, if we wanted, the perimeter is 14. So if we want to just use our rule, and what is the perimeter of a similar rectangle with a width of 9? So here's my new rectangle. If the width here was 3, and if the width here was 9, that means that our scale factor is times 3, because 3 times 3 is 9. So I would take my original perimeter, 14, and multiply that times 3, or the scale factor. And 14 times 3 is 42. And again, we can work the problem out because we can, this would be 9, Scale factor is 3. 4 times 3 would be 12. 12. And we could just add that up and see 24 plus 18 is 42. So you can use your rule or you can draw a picture. Okay? All right, so now let's look at the next one. It says, as previously noted, a rectangle that was 24 inches by 20 by 24 inches has an area of 480 inches squared, which quadruples because the scale factor is going to be 2, and so it's going to be times 2 times the power of 2, because the area of the other rectangle was half 10 by 12, which was 120. So the rule says that because if you enlarge or reduce a polygon by a factor of k, that's the scale factor, then the area will change by a factor of 1 to k squared. In other words, a to b becomes a squared to b squared. So let's look at a couple examples here. So here we have a square, and it has a diagonal of 10, which means hopefully you recognize your 45, 45, 90 triangles and would know that this would be 5 times the square root of 2. Okay? So the sides are 5 times the square root of 2. So if we want to know what is the area of this, we would do 5 times the square root of 2 times 5 to the square root of 2. You multiply 5 times 5, and that's 25. Multiply the square root of 2 times the square root of 2, which is 2, and we get 50. So the area of this square is 50. So if we just follow the rule, we would say 50 times our scale factor, which is doubled, so 2 times the power of 2. So that would be 50 times 4, which would be 200. If you want to look at a picture of it, which I think is always a good idea at this point, let's draw it. Okay, this is supposed to be double. Obviously it's not, so, but the sides, instead of being 5 to the square root of 2, be 10 to the square root of 2, because that is doubling the sides. So if you multiply 10 times the square root of 2 times 10 to the square root of 2, 10 times 10 is 100. The square root of 2 times the square root of 2 is 2. And 100 times 2 is also 200. So those are the two different ways you can do this problem. Is you can follow the rules, or you can always just draw yourself a picture and see exactly what happens. So I would ask you to pause the video at this point and see if you can do the quick check yourself. Okay? So hopefully you're going to do that, but let me go ahead and work it out. What would be the area of the isosceles triangle if the dimensions were halved? Okay, so it doesn't show us what the area of this one is, but we know the rule is base times height divided by 2. It's an isosceles triangle, so if we draw the height, it cuts the base in half and would make this 6. You could use Pythagorean theorem, but this is a 6, 8, 10 triangle, okay, or use Pythagorean theorem. So the area of this triangle, the base is 12 times the height of 8 divided by 2. So that would be 48. So the area of this triangle is 48. And if we just simply follow our rule, we're going to take 48, we're going to multiply by the scale factor, which is 1/2 squared. So that is 48 times 1/4, or 48 divided by 4, which is 12. And again, we could draw the picture ourselves. We could just cut everything in half. Would make this 6. And so when we drew the height, we would have this is half of 6 is 3, so we would have a 3, 4, 5 triangle. So base is 6 times the height of 4 divided by 2 is also 12. So you can do it by either drawing the picture or following the rules. It's going to be a really good idea if you learn the rules. It's going to make it easier. Okay, let's see what is next. So we still have quite a bit left here. Let's see if we can finish it. A circular pond has an area of 100 feet squared. So let's just try the rule to cut down the thing. So this is squared feet, okay? So we're talking about area. So we have 100 pi, okay? The scale factor of a similar polygon is 1 to 2. So that either means 1 over 2 or 2 over 1. Do we want it to get bigger or smaller? And it says, what is the area of the smaller pond? So that means we want it to get smaller, so we would have to use the 1/2. So we would take 100 pi and multiply by 1/2, and we're talking about area, so to the power of 2. So 100 pi times 1/4, and that would be 25 pi. Okay. Quick check. Please pause and try it yourself. The perimeter, this time it says perimeter, of a square is 20. So perimeter, that means 5, 5, 5, 5, 5. Okay. The scale factor of a similar larger square is 2 to 3. That means my scale factor is either 2 over 3 or 3 over 2. I want it to get larger, so I have to multiply by something that's going to make it larger. So I'm going to take my perimeter, which is 20, and I'm going to multiply by 3 over 2. This is perimeter, so we're not going to raise it to a power. We're just going to simply multiply by the scale factor. And that is going to be 20 times 3 is 60 divided by 2, which would be 30. And that would be, that is the new perimeter, is 30. Okay. Example 6. Triangle QRS and WXY are similar isosceles triangles. The area of QRS is 540 centimeters squared. 540. QS is 30 centimeters long, and WY is 10 centimeters long. So that means the scale factor is, what do you multiply by 10 to get 30? Well, it would be 3. My scale factor is either 3 or 1 over 3. Or you could put 30 over 10 or 10 over 30, which simplifies to 3 or 1/3. And they want to know what is the area of WXYZ. That is a smaller one. So that means that we are going to multiply by the number that gets it smaller. So if we had 540, we are now going to multiply that by 1/3. And we're talking area. So it is 1/3 squared. So it's going to be 540 times 1 over 9, or 540 divided by 9, which is 60. And again, if you want to work the problem out by drawing the entire problem, you can. Let's see, I have just a little time left. Let me see what we have left to do. We only have one problem. Let's see if we can finish it. Rectangle in the area of 70. The rectangle STUV has 72 square units. So square units. So 12 times what is equal to 72. So it's just division. And 72 divided by 12 is 6. So that means that this has to be 6. what is the area of the other one? So